What makes this question difficult? Well, because it doesn't fit into this, you can't even start this until you've got the right-hand side. Okay. So if you got presented with this, where would you go? Okay. I sort of gave you a clue. I said, well, you have to work out what this pattern is going to be, and then you can start to establish the proof based on our principle of mathematical induction, right? So how do you find out? What might it be? Well, you use our good old friend, guess and check. Now, guess and check is not the greatest tool in the world, but it will do enough to help us get a pattern. Okay, that's all we're after. Okay. So, for starters, rather than having question marks over here, I need to call this thing on the right something, give it a name, so that I actually have a statement, right? So, since this is a series, it's not an AP or a GP, but it's a series nonetheless, I'm going to call it S of n. Series, the sum of the first n terms, because that's how many I have over here. All right. Now that I've got some names and some labels, I can start to talk about some conjecture. Okay. So I'm going to draw up a table for myself. I'm going to have values of n over here, and then I'll have values for the whole series on the other side. Okay. So let's draw ourselves a table. Okay, now, how many values for n do you think I should test? 3? 4? 5? 3. Enough till you see a pattern. Okay? I think I got to 4 and I started getting suspicious, and then I did 5 just to really double check. Okay? So that's how many I'm going to do with you now. Let's do 1. Okay? How many terms am I going to have? If n's equal to 1, I'm going to have 1 term, right? Because this series has n terms in it. Okay? That means just the first one. Okay? So it's 1 on 2 factorial, which is just a half. Okay? If you're not watching this, by the way, that's fine, but let everyone else concentrate on it. All right, that was easy enough. Let's do the next one. 2. Okay? So I'm going to have the first 2 terms now. So 1 on 2 factorial plus 2 on 3 factorial. A half plus, now, 3 factorial is 3 times 2 times 1, 6, right? So when I've got 2 on 6, I'll have a third. Okay? What's a half plus a third? 5/6, right? 3/6 and 2/6, so 5. Okay. Nothing's jumping out of me yet. Let's keep going. Number 3. Now, rather than, because this is a series, this is a nice handy trick, right? Rather than work out the first 3 terms from scratch, right? When n equals 3, I can take the first 2 terms and just add the next one. And I already know what the first 2 terms are, right? So I'll just save myself a bit of work. This is going to be the previous one, right, when n is equal to 2, plus the third term. Okay, does that make sense? So another way I could say this, maybe, is this is S2, right, plus term 3. That's why you end up with S3. Does that make sense? Okay, anyway, that was an aside. Alright, what's this thing equal to? 5/6 plus, what's 4 factorial? Now, I don't have to work out all of what 4 factorial is, because I know I can get rid of the 3, right? So I guess that's going to be 1/4 times Mr. 3 times 2 times 1. Is that okay? 5/6 plus 1/8. Is that right? Yeah, okay. I'll need a common denominator here. I'll save you some time. 23/24. Alright. Still, nothing's really jumping out at me, though I notice there's this, these are always 1 less. It's kind of weird. Let's see if we can make a consistent pattern out of this. So 4, I'll take the first 3 terms, and I'll add the next one, which is 4 on 5 factorial. 23, 4. Now, 4 factorial was 24, if I had included the 3. So 5 factorial would be 5 lots of 24, which is 120. So I'm going to have 4/120. So that's 1/30. Is that checking out? Yeah, good. And I'm actually going to have to come back to 120 to get a common denominator. Okay, so let's see here. So far I've got, I think, something consistent, right? At the very least, I've got a fraction. And what's the fraction made up of? It's some number, and on the top, it's the number minus 1. Okay? Now the question is, what's the number? I did one more to be sure, okay? But if you've been using a calculator to work out your bigger numbers, like 5 factorial, you might already recognize what the number is, right? When I go to 5, I'm going to go 119 on 120 plus 5 on 6 factorial, which is 5 on 720, which is equal to, I can't remember what it's equal to. Oh yeah, I should be able to guess that actually. Okay, so good thing is I've got my x and x minus 1 pattern. Okay, now let's have a look at these denominators, because that's the important number it seems. 2, 6, 24, 120, 720. You've been punching factorials into your calculator, right? Can you recognize it? 720 is 6 factorial, right? I just got it there. And 120 is 5 factorial. And there's 4 factorial. Well, that's kind of obvious, isn't it? Okay. So, what conjecture, I think that's enough, isn't it? What conjecture would you make? I think we want to say that S of n, that's sum, right? On the denominator, we've got something factorial. What's the something? It's always one more than our value for n, right? So if it's one more, that's n plus 1, right? And then you take the factorial of the whole thing. What do you have on the top? That minus 1. Okay? Now, as we go through this, I can now start to actually test it out, right? And prove it, okay? So let's test it see if our formula holds out for our first allowable value, okay? So hopefully the numbers are pretty easy. Let's have a go. Left-hand side, that's equal to 1 on 2 factorial, which is a half, okay? Right-hand side, now's the moment of truth, because this is the part that we came up with, right? What do you got on the top? You've got 1 plus 1 factorial minus 1 on 1 plus 1 factorial. Okay? 2 factorial minus 1 on 2 factorial. Success! I'm not going crazy. Okay. So at least I proved it for the first allowable value. Now what do? TA, assume. Okay? Just do a straight substitution for yourself. All the way up to k. And I'm assuming it's this. Oops, no, that's it. Okay, so now what do I have to prove? I can fit it over here. Now, the reason why I'm going all the way through and showing you the working is because maybe thinking in factorials, that mode of thinking has gone out of your mind from like year 8, maybe. So you've got to get yourself back into gear so you can factorize and get everything simplified the way it needs to be, okay? So for k plus 1, I'm going to have all of these first terms. Again, I'm going to include that second last term, this one, because it'll make my substitution from the assumption easier, okay? So I'll have k on k plus 1 factorial here. What's the last term of this series? It'll be k plus 1 on the top, and k plus 2 factorial on the bottom, okay? So that's equal to okay. So the stage is set. Because this is a series from practicing those before, you know when you've got a series, it's usually easiest to start on the left-hand side because you've got all of these terms that you can sub out with your assumption, right? So let's see. Left-hand side. Again, just to save a bit of space and your time, I'm going to skip a line. I'm going to put the assumption right in here, okay? And it's sort of, it actually is sort of obvious, right? I've written it deliberately that way. There's my assumption, right? Or the left-hand side of the assumption, anyway, okay? So I'm going to substitute in this. By assumption. By the way, I've been walking around having a look at people's answers when they've been asking for help and that kind of thing. People keep forgetting to put this in. It's vital, okay? It's really crucial. If you don't have it, it demonstrates you sort of just doing this mindlessly, you're not remembering. This is a crucial step, right? In fact, this is the step that makes it induction, okay? So don't forget to put that in, all right? Now, all I have to do is get these on a common denominator, but again, if you're thinking in factorials, how do you do that? The difference between this and this is a k plus 2, right? That's the next step along. So if this was, say, if k was, say, 10, okay? This would be 11 factorial and that'd be 12 factorial. So to go from one to the other, I've got to multiply by that last term, k. Okay? Sorry, k plus 2. So, here we go. K plus 2 factorial times all of this. Now when I multiply, whoops, that's wrong. Not factorial, I just need the k plus 2. When I multiply the denominator by k plus 2, it turns into k plus 2 factorial. Okay? So by that logic, I can put them all on a single denominator. Okay? Again here the same thing happens, right? That k plus 2 and that k plus 1 factorial combine together, right? And they'll be just k plus 2 factorial. Okay? Then I've got minus 1 lots this, so minus k plus 2 plus k plus 1. Okay, I'm almost there. You can see these guys are just going to cancel out with each other. K's cancel. That minus 2 plus 1 becomes minus 1. And we are home and hosed. Okay, so it's equal to the right-hand side, and therefore you can make your explanation by the principle of mathematical induction. It's true for n equals 1, 2, 3, and so on.